So this video lecture, we are going to discuss about black box testing. In software testing, there are two testing strategies. One is white box testing and other one is black box testing. So white box testing will test the internal logics of the software, whereas black box testing will test the behavior of the software. So that is why black box testing is also referred as behavioral testing. So black box testing will mainly focus on the functional requirements of the software and the information domain of the software. This testing will help you to identify the errors in the following categories, either missing function or an incorrect function. Then if there is any interface errors or any errors with the data structures or uh, performance errors, and maybe initialization and termination errors. So these are some of the errors which a black box testing will help you to identify. So there are two methodologies available in black box testing. One is equivalence partitioning and the other one is boundary value analysis. So now let us see equivalence partitioning. So here we will attempt to develop test cases for a program. Okay. So when I say I'm going to develop a test case, always my test cases should cover a valid and an invalid class. Say for example, I wanted to test a system which is going to accept an input in the range 1 to 10. Let me explain you. So my program is going to accept an input from 1 to 10. To check whether my program is working fine, I have to give an input within the range 1 to 10. I have to give an input less than 1 and I have to give an input greater than 10 to check whether my program is correct or wrong. Okay. So when you are taking the test cases to check your program, you have to take test cases from a valid class and from an invalid class. So that is what equivalence partitioning means. So here is an example. Like if your input is a range, you have to use three equivalence classes. One is a valid range and one is an invalid, that is less than 1, and the other equivalence class is greater than 10. Then second guideline is, if your input condition is a specific value, say I want to get x is equal to 250, then to check whether I am getting the perfect output, I have to give one valid test case, that is my x is equal to 250, and I have to give two invalid data, that is my x is less than 250 or greater than 250. Then third guideline, if my input condition is a member of a set, say for example, I have taken three values in a set. So here in this case, I have to give one valid, which is a member of a set, and one invalid, which is any other number other than the set. Then fourth condition is, if my input condition is a Boolean value, so in this case also, I have to take one valid and one invalid classes. So whenever you wanted to test the system, you have to design test cases. When you are designing the test cases to check your system, you have to take the test cases from a valid domain and also from an invalid domain. So this is what equivalence partitioning means. Okay. So adding to equivalence partitioning, we use another concept called boundary value analysis. So why we go for boundary value analysis is, most of the errors we get only at the boundaries of the input domain. So we go for using the boundary value analysis. So here also you have some guidelines in choosing the test cases for testing your program. So first guideline is, if your input condition is in the form of a range, when you are generating the test cases to check your program, you have to take the boundary value. Say for example, my boundary value is A and B, then I have to include the test cases, the value A, B, and a value just above and below A and B. Then the second condition is, if my input condition is the number of a value, then I have to take the minimum value, the maximum value, and a value just above and below the minimum and maximum value. Same thing I have to apply for my output as well. And the fourth guideline is, if I am using any program data structures like an array, then I have to take the minimum boundary and the maximum boundary to check whether my program is correct or not. So in black box testing, we will design test cases to check whether the program is working fine or not. So these are the guidelines you have to follow when you are designing the test cases. Let me explain you with an example. So here is a sample, you have a program which will read an input in the form of a day, month, and year, and it will print the previous day as a output. So this is the problem. So here your input can be in the range 1 to 12. The day can be in the range 1 to 31, and the year can be in the range 1900 to 2000. So this is the condition of the program. So now you wanted to check this program whether it is correct or not. For that, to check the program using black box testing, you will generate test cases. So as per the guideline, if your input is in the form of a range, you have to take the boundary values and a value just above and below the boundary values. So for the month, you can take 1, 12. Value above and below means you can take 0, you can take 2, you can take 11, and you can take 13. So these are all the different values you can take as a test case for the month. Then when it comes to a day also, again it is a range. So you can take 1, 31, a value above and below the boundaries, that is 0, 2, and 30 and 32. Similarly, year is also in a range. So 1900 to 2000. So I can take 1900, I can take 2000, I can take 1901, then 1899, then 2001, and 1999. So these are all the sample test cases. You can check whether your program is working fine. If it is a valid, then it will print the previous date. If it is an invalid, then it will print the output as invalid date. So this is black box testing. This is how you design the test cases using black box